A rotary actuator is an output device for a fluid power system that delivers an oscillating motion over a limited range of less than one full revolution of a circle. A true rotary actuator produces work by direct action of fluid pressure against internal vanes. Work is defined as a force applied over a distance. Rotary actuators produce a special type of rotational work called torque. Torque occurs when a force acts on a radius. Since rotary actuators operate at low speed with high torque, torque output rather than the horsepower is used for the rating and identification purposes. Speed is a secondary consideration when choosing a rotary actuator for a particular application. The typical units of measurement for torque are foot-pounds. For example, if a rotary actuator with an arm length or radius of 2 feet were used to lift a 200-pound weight, then the resultant torque required to accomplish the work would be 400 foot-pounds. Due to the way in which it is calculated, there are an infinite number of possible system configurations that would also yield a torque equal to 400 foot-pounds. In this example, torque is easy to calculate because the lever arm is at right angles to the force exerted on the arm. However, when the angle between the force and the arm changes to something other than 90 degrees, an additional calculation becomes necessary. When the lever arm moves, the length of the arm can no longer be used as the radius of the system. Instead, the effective radius must be determined. To calculate the effective radius, multiply the length of the lever arm times the sine of angle A. Sine is a trigonometric function for a right triangle that relates the ratio of the side opposite of a given angle to its hypotenuse. Sine has values that vary from 0 to 1 for angles between 0 and 90 degrees. When the lever arm is in the vertical position, the angle between the rope and lever arm is 0. The sine of angle 0 is also 0. Therefore, when the lever arm is vertical, the torque will be equal to 0. As an angle increases, the sine also increases, which will increase the torque. When the lever arm is at right angles to the force of the weight, the angle is equal to 90 degrees. The sine of 90 degrees is equal to 1. It is at this angle that the torque is at its maximum value for the system. Understanding the relationship between the output torque required and the physical setup of a fluid system enables designers to determine the appropriate rotary actuator for each unique application.